So let's start by thinking about graphs of linear functions. So first of all, we have to define what a linear function is. So what's a linear function? So what do I mean by a linear function? We know what functions are, but we have to figure out what linear functions are. So linear functions are going to be any function of the form where y will be of the form m x plus c. Okay, so that's where m and c, so both these guys are going to be so m and c are going to be real numbers, r on the real line. So there will be r on are real numbers, r real numbers, which means they are on the number line. That's all that it means. They can be any real number. So that's what we mean by linear functions. Okay, and this is a very important class of functions. We learn later on why they're important. For now, let's just assume that linear functions are important, and we want to study functions which look of the form y is equal to mx plus c, where m and c are any real numbers. For example, I can have an equation like y is equal to 2x plus 3, or y is equal to pi x plus square root of 2. So any of these would work out as linear functions. Okay, so now what we're going to see is that when we plot them, we'll get straight lines. That's an important idea. So another important thing that you need to note is when we plot them, we will get straight lines, and whenever we get straight lines, actually it means they're a linear function. Okay, so straight lines are a hallmark of plotting linear functions. Okay, so we haven't shown this, but I'm just telling you this is what is going to come. But before we begin, we have to figure out what a straight line is, right? So maybe what you can do is you can say that what's a straight line? So maybe you can say, oh, this is a straight line, right? So you have to first say, okay, so what's a straight line? So maybe you say, oh, this is a straight line, okay? Or maybe this is a straight line. They all look like straight lines, right? They're all straight lines. That's what we mean. But I mean, just showing them is not sufficient for us to figure out what do we mean by a straight line, right? We have to define what a straight line is, because we want to show that linear functions, when you plot them, you get straight lines. So we have to be very clear mathematically of what we mean by a straight line. So we know all of these are straight lines, but we want to give a more precise definition of straight lines. So let's get rid of them and put up a new background, and let's draw some Cartesian coordinates and see where we can go. So let me draw some Cartesian coordinates. Here's my y-axis, here's my x-axis, and what I'm going to do is that I'm going to label this as 1, as 2, as 3, and as 4. Here I have 1, 2, 3, 4, 5, 6, 7, and let me draw a line, and the line that I'm going to draw is going to be a line which is going to go, and let's draw this line. So here's the line that I'm trying to draw. So this is a straight line. Okay, we all agreed this yellow line is a straight line, but what does it really mean for it to be straight? So let's think about it, okay? So first of all, please note that so this is a way that I'm going to characterize what a straight line is, that whenever I move forward, so let's look here, I move forward by 1 unit here, okay? How much do I move up by? Well, if I move forward by 1 unit, you can see I'm moving up by 2 units, right? Because I go from 2 to 4, I'm moving up by 2 units. And you can also see that it doesn't seem to depend on where I start from. So I could even start from maybe 3.5. So you can see if I'm right over here, so you can see if I start from here and I move forward by 1 unit, what I'm going to do is I'm going to end up over here. This is moving forward again by 1 unit. And if you measure how much height I've gone up by, you'll see that this distance, which is this one, is exactly 2 units again. So maybe we can say that for the same change in x, which is when x changes by 1, y changes by the same amount. In this case, it's 2. Okay, so this would be a way to characterize straight lines. And you can see that if I were to put a kink in the line, let's say I put a kink in this line, and let me put a kink in this line right over here. So let me first have 5 and maybe here 6, and let me put a kink maybe at 4. So I'm going to put a kink at 4 and show you that, for example, if I put a kink here, and what I do is that I'm going to go like this. So now you can see this is not a straight line, but what have I done? Now you can see that for every 1 unit that I move forward by, so if I move forward by 1 unit here, so if I move forward by 1 unit, I'm moving up also by 1 unit. So you can see that the red line is different from the yellow line. In the yellow line, whenever I move forward by 1 unit, I was moving up by 2. But in the red line, when I move forward by 1, I move up by 1, and that's what generates a kink. Okay? So now, in order to convince you, so hopefully now we have a clear definition of what we mean by a straight line. By a straight line, we mean that when we move forward by a fixed amount, in this case we are saying 1 unit, then you go up by the same amount. It could be 2 or 1 or 7, but it's always the same amount. And you can see for the yellow line, it's always 2 steps up, and for the red line, it's always 1 step up. Okay, so now let's think about why is y equal to 2x a straight line. Okay, so let's think about it. So this is, let me first get rid of the background, and then it's just easier to think about it, and then we'll bring the background back. So here is y is equal to 2x. So y is equal to 2x is the equation. So let me put a little table up for you. So this is x, this is y. So when x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. When an x is 4, y is 8. I also have, I think, maybe a 5. So when x is 5, y is 10. Okay. So here you can see that I have just plotted these points in the yellow. All these points have been plotted over here. So now let me connect these points. I'm just going to connect these points. Now please note, I'm not claiming this is the line y is equal to 2x. This is not my claim, okay? This is not my claim. All I'm saying is this is a straight line. I've drawn it connecting these points, which I got from y is equal to 2x. But this may not be the line y is equal to 2x. Now what's so special about this line? Well, please note right over here, I have this triangle. Right over here I have this triangle in which when I move forward by 1 unit, I'm going to go up by 2 units, right? This should be clear to you. So let's move this triangle, and let's move this triangle, and you can see that throughout this line, I'm going to make it move along this line, and you can see that this line is exactly the line that when I move forward, so you can see right over here, when I move forward by 1, so you can see when I move forward by 1 unit, I go up by 2 units, right? And this is characteristic of this line, right? Throughout this line, wherever I go, whenever I move forward by 1, I go up by 2, right? Now, let's look at the line y is equal to 2x. So now let's look at what y is equal to 2x looks like. Not the line, but what does y equal to 2x look like? So let me get rid of the background and let's go over here and maybe erase this. And now let's look at y is equal to 2x. So let's say pick any point, okay? So pick a point x naught. So let me pick a point x naught here. So if I pick a point x naught, okay, then I know that y naught is going to be equal to 2x naught. So for example, over here, x naught could be, let me turn on the grid again. So x naught could be exactly this point. So this point right over here, I'm dropping it. So this could be x naught, and this point right over here would be y naught. Okay, so this would be y naught, and this point would be x naught. Okay, this is what I mean. Okay, so now if I have y naught is equal to 2x naught, let's say I move forward by 1 unit. So if I move forward by 1 unit, then let's say x1 is equal to x naught plus 1. I've moved forward by 1 unit. So if this is x naught, then x1 would be right over here that I drop, and this would be x1 because I've just moved forward by 1 unit. So now y1, which is going to be equal to, so y1, which is going to be equal to 2x1, should be equal to 2x naught plus 1, which is equal to 2x naught plus 2. But please note that y naught is equal to 2x naught. So this means y1 is equal to y naught plus 2, which means y1 minus y naught is equal to 2. So what we are saying is that y is equal to 2x, the graph of y is equal to 2x is a special graph that whenever we move forward by 1, y changes by 2. But that's exactly the line that we drew over here. So hopefully now I've convinced you that y is equal to 2x is actually a straight line, and it's okay not to have to go through this argument again. Just pick a few points like we did in the table over here and connect the points and get your graph. Okay.